Hello, I'm David Adler, and I'm happy to present to you today the LXD 6.6 release notes. This release includes a couple of really interesting features, like instance placement groups to manage your instance in a cluster, and also the Kubernetes CSI driver for an improved storage support. And you can see there's a couple of other very interesting features, HPE Alletra storage driver, which is also available in the UI. It will be demoed later on, together with the CSI driver and placement groups. And I will just quickly browse through the release notes here before starting my demo with this one, mobile experience improvements in the UI. So this is the UI in the mobile size, and we see the instance list now fully works. We can go to detailed pages. The detailed pages also scale nicely to a smaller screen. The networks list uses this card layout. If we go to a network detail, we also can browse the configuration of a network or of a storage pool. We just have one pool here, and we can browse what it's used for. You can expand here. So all of these pages have been reviewed for improved responsiveness. Another thing we worked on is reporting for bulk operations. So if we bulk start these 3 instances here, they get started, we get a notification, and new is this model here to show us the details of the bulk operation. As we stop them, we also get a success. And we can again explore the details, but then comes the interesting bit when we delete them, because I prepared them. One of them will fail, and before there was no way to understand why. Now we see one of the instances is delete protected, and these are the ones that have been deleted, and this one is still there. So we can go ahead and remove the delete protection. Delete this one also to finish our operation. And that's all from me. I will now hand it over to Omar, who will show you SSH keys.
Hello. Today I want to demo to you a new feature for LXD UI, and that is SSH key generation. Previously, if you wanted to add a key to your instance, you had to create it somewhere else, and then you could come back and copy it within the UI. But now it can all be done within the UI. I have the instance page open here. You can go to your instance, configuration tab, scroll down to the SSH keys section, click on new SSH key button, and here where you would usually copy your key, we have a new tab that is generate key. You press on it, and then you can see automatically your key is generated. All you have to do is download your private key to your local machine, and then you add the key and save the change. And that's it. You have a key in your instance.
Hello everyone, my name is Nkira and I am a software engineer on the LXD UI team. Today we're going to be talking about HPE Alletra, a new storage backend in the LXD 6.6 release. So let's jump straight into storage pools, and we're going to create a new pool, and I'm going to name this one HPE Alletra. Amazing. Let's change the driver. And here we can see all of the different configuration options that we have for this new backend. We can set the address, our user, password, and the common provisioning group as well. We can go to the HPE Alletra tab and find a few more other configuration options that we can mess around with. From here, we can choose whether to verify our HPE Alletra certificates, specify target addresses for LXD to connect to, and also choose how volumes will be mapped to the local server. And that's all for now. Thanks for listening.
Hello, everyone. My name is Caden, and I am a software engineer with LXD. And today I'm going to show you how to create a snapshot of an instance and its attached storage volumes. I've already created a virtual machine called V1, and I have also created a couple of storage volumes of the content type file system, vol1 and vol2. This also works with block volumes, and this works across all storage drivers. However, the storage volumes must be exclusively attached to the instance you are snapshotting. So I'm going to start by attaching those storage volumes to our instance. Okay, and we will also attach vol2. Normally, when creating a snapshot, we would just include the instance name, and this would snapshot the instance's root disk. To take a multi-volume snapshot, including those attached storage volumes, we will include the disk volumes flag with the all-exclusive value. Now, if we take a look at all of our storage volumes, we can see that we have a snapshot here of the instance's root disk, And then we also have snapshots for both of those attached volumes. And we have a description here indicating that they were created alongside the root disk snapshot. We've also included a option to just snapshot the root disk, and using the disk volumes flag with the root value basically just mirrors the exact same behavior as snapshotting without the flag at all, and just takes a snapshot of the root disk. Placement groups allow you to control how instances are distributed across cluster members. You can either spread instances across different members for high availability or workload distribution, or you can compact them onto the same member for performance and locality, which can be useful for minimizing network latency across workloads or maximizing resource sharing performance. I have a 4-member LXD cluster here, and I will show you how to use placement groups by demonstrating a placement group that uses the spread policy and the strict rigor. You can create the placement group. Let's call it my PG. I'll set the policy to spread and the rigor to strict. And what's cool about placement groups is that they don't just work for instance creation, but they are also respected during evacuation as well. So to demonstrate placement groups, I'm going to create some instances. We can just create empty instances here without an image. And I'll set the placement group configuration key to the name of the group we just created. And with the spread policy, we expect each instance we create to land on a different member. And with the rigor set to strict, that means we will only be able to place as many instances as we have cluster members. If we were using the permissive policy, we could continue to create instances. And listing our instances now, we see that each instance is located on a different cluster member. Cool. For more details on placement logic for the different policies and rigor levels, you can check out our documentation. There's also more information on the differences between instance creation and cluster member evacuation and how placement groups are used during that placement logic.
Hello, my name is Julian Pelizeus. I'm a member of the LXD team, and today I will demonstrate you the features we've added to the LXD recover command. Over here on my terminal, you can see I have an LXD with currently 2 storage pools. The first one is called pool 1, and it currently hosts one system container C1. However, there's a second pool, pool 2, using the PowerFlex driver. And as you can see here, it's currently not used by any resources known to LXD. However, I know that on the storage array in this pool, there are still some resources left because they are from a previous installation of LXD from a different system that failed at some point. So what I want to do now is I want to recover those resources. In order to do this, we have the LXD recover command. And if we now run it, it asks us if we want to scan additional pools. We say no. We need to confirm that we want to scan our current 2 pools, which are pool 1 and pool 2. And now LXD will basically scan for unknown volumes on those 2 pools. As you can see here, it now found the virtual machine V1 and 2 additional custom volumes. In order to get them recovered, we say yes, and LXD will now add them back to the database so that we can use them. Now, when we run LXD ls, we can see the virtual machine is there, and we can actually start it to get our workload back up and running. Now, there were also 2 additional custom volumes, so when we do LXD config show v1, we see those are attached to the virtual machine. And by doing this, we were basically able to recover everything from those custom volumes. If we now do LXD storage volume show pool 2, and for example pick v1 block, we can see we were not only able to recover its original creation date, but we were also able to recover additional configuration that was once set on the volume. For example, the user.node config key, which is set to important files. Now, this was not possible before. Before, we were just scanning the storage pools for custom volumes by their names, which didn't allow us to restore additional configuration for custom volumes. Now, together with this change, we also enabled recovery for both the PowerFlex driver and the pure storage driver in LXD.
Hello everyone, my name is Din. I'm a software engineer at Canonical, and today I will present to you LXD CSI driver for Kubernetes. It is supported from LXD 6.6 release, and it is an implementation of container storage interface that integrates LXD storage backends with Kubernetes. Effectively, it allows storage volumes to be created dynamically upon request and automatically attached to the containers running inside Kubernetes. The prerequisite to use LXD CSI is a Kubernetes cluster running on top of LXD instances that are located within the same LXD project. Other than that, one needs sufficient permissions to create an LXD identity in LXD and sufficient permissions in Kubernetes to deploy the CSI driver. Okay, now I will show the CSI installation, and afterwards we will provision one volume using it. So as you can see, I have a single node Canonical Kubernetes deployed on top of the LXD virtual machine. And the first thing I'll do is enable the LXD volume management API to allow CSI to create and delete volumes. Next, I'll create the authentication group and set the permissions or allow viewing the project, editing volumes and editing instances, which is important so that the CSI can attach and detach volumes from the instance. Afterwards, I'll create the identity of type devLXD and issue a token which will be provided to the CSI. With that, everything on the LXD side is done, and now we can move to the Kubernetes itself. First, we will create the namespace, and within the namespace, we will create a secret named LXD CSI secret and use the token that we have previously created. With that, we can install the CSI driver. We'll install it from the Helm chart using the Helm chart from the OCI image that is available on GitHub Container Registry. In the time of recording, the latest version of 0.0.4, and in a few moments, the CSI will come up. So once the CSI is deployed, all we want to do is create a storage class to map with the existing LXD storage pool. In our case, this is Kubernetes, the Kate storage pool, as we can see. And now we can start deploying the volumes. So we will first provision a persistent volume claim that will references the created storage class and will request a block volume of size 256 megabytes. So once the persistent volume claim is created, it will be in a pending state because it's waiting for the first consumer. So let's create the pod and the reference this persistent volume claim. So once the pod is created, the persistent volume claim should go into the bound state. Let's wait for the pod to get ready. Here we go. So the persistent volume claim became ready, bound, and finally the persistent volume also exists, and we can check in the LXD storage pool that the volume is created. Thank you very much, and see you next time.